Hello, this is Pat Kelly. Okay, in this problem, they give us this y equals x minus 2 raised to the x plus 1. And the directions say to use logarithmic differentiation to find dy dx. I'm going to tell you right off the bat is I think they were a little bit too nice to you in the directions. And I say that because down the road you're going to be given functions like this and just be asked to find the derivative. Or you yourself are going to decide, I need to take the derivative. What you have to build up to is recognizing which differentiation technique you're going to use. So being told that you're going to use logarithmic differentiation here is kind of like training wheels, but you want to start thinking as you're doing these problems, well, why? Why am I using logarithmic differentiation? So then you'll be able to decide that on your own later on, okay? So here's my thought right off the bat, is notice there's a variable in the base of this expression, but there's also a variable in the exponent of the expression. That's when you want to be thinking logarithmic differentiation. If I only had the variable in the base, I'd use my good old power rule from way back when. If I only had the variable in the exponent, we'd be using our exponentiation techniques that we just learned recently. So a variable in both the base and the exponent is a flag to me that I need to use logarithmic differentiation. Okay, now that that's out of the way, let's do it. Here's the process. The first step is actually an algebra step. The algebra is to take the natural log of both sides of the equation. I'm allowed to do it as long as I do it to both sides. So I'll get the ln of y equals the ln of this entire right-hand side, and if you let me skip one step, the reason I'm taking the ln of the right-hand side is that property of log that serves us so well. The exponent inside a log becomes a coefficient in front of the log. I'm taking the ln of the entire right-hand side, but if you'll permit me to do this just in this step, I'm going to take that property of logs, which allows me to take the exponent and put it in front as multiplication. I'll just write that in this step, x plus 1 times, and then I have the natural log of x minus 2. Okay, now that was an algebra step. My next step is going to be a calculus step. The calculus step, I'm going to do my differentiation, of course, but it's still that whole golden rule idea is you do it to both sides of the equation. So when I go to take the derivative on the left-hand side, it's actually implicit differentiation here, where the derivative of natural log of y is 1 over y, but then you need to remember to multiply by the derivative of the argument inside the logarithm, which is dy dx. And remember, of course, that's ultimately what we're looking for, so that's what we're going to solve for in a few more steps. Okay, on the right-hand side, I'm still doing my calculus step, where I'm doing the derivative of the right-hand side now. And recognize that overall you've got multiplication. So I'm doing a product rule. Product rule that you know and love is derivative of the first, which is just 1. Second left alone, natural log x minus 2 plus the first left alone times the derivative of the second, and the derivative of the second is 1 divided by the argument. Okay, so there's my calculus step. Make sure that makes sense to you. Not too much more to do here either, because we're looking to solve for dy dx. So I'm going to take this 1 over y that's connected by multiplication. Real easy algebra is I'll throw it to the other side. y dx equals 1 over y just becomes y times. And I'm pausing here just because if you recognize it's 1 over y and I'm going to multiply by y right here, here's a good time to replace y with what it equals. So it's this entire exponential expression. X minus 2 parentheses raised to the x plus 1. And now all the stuff from up above, the step above. Natural log x minus 2. Plus, I'm going to do a tiny little bit of cleanup here just because of the fraction. It'll look nicer as x plus 1 divided by x minus 2. pretty good, but always be careful. When I multiply it over that y, it's being multiplied by the entire expression that was up above. So parentheses, square brackets, or some kind of grouping symbol, just to make that clear. Okay, and that's my dy dx for this expression. Hope that helps. Thanks.